understanding that only we are going to propose the solutions. Why is somebody removing? Someone is removing others. Okay.
No, sir. Actually, to record it, it is automatically removing two people. They can rejoin. It seems it is
Okay.
showing like that.
Sure. Okay. Fine. Okay. So that is the definition of the force. Then we moved on to what are the different perspectives or scopes we can look at the nature. So we have three different scopes in principle. The that is triple M, that is mentor, measure, and model, or you can call it as model, measure, and mentor. At each scope, you can see at a different level. In each perspective, you can see at three different levels. So, what are the different levels? Anybody can please remind me? What are the different levels of bio inspiration? Different levels.
Organism level,
Mm.
behavior level, and ecosystem level.
Yes, organism level, behavioral level, and ecosystem level. Those are the three different levels. In any perspective, we have to look into. So after that, we came to the concept document. So in the concept document with example, I explained. So that means first I covered one example, that is hierarchical construction. Then I explained how to make the concept document. So in the concept document, we have the idea about the problem, or we'll probe the problem first. Then we look at the bio inspiration. Then we convert this biological inspiration into an engineering problem. Then how we convert something into an engineering problem also we discussed. So before that, we also took into account how we are understanding the systems. So in understanding the systems in principle, I'm not completely saying that this is the ultimate method. In principle, what we are saying, we defined 4 steps. What are the 4 steps in understanding the nature? We discussed how you are going to understand the nature. Anybody else? So because these questions will help you to remember the things here itself, instead of going and reading again and again. So here you can participate in the discussion so that you will remember them. Yes. So manifestation of knowledge. First consideration should be manifestation of knowledge. After that, what we will do? Information
Information
flow.
flow.
Yeah, immediately there comes the information flow. So after information flow, but information flow only happens when you take a
Direction.
direction. That means those direction you can decide on based on keywords. So after getting the information, what you are going to do, you are going to analyze it and then interpretation. So that is what is going to happen in the process of understanding. So when that understanding comes, then you convert the natural system into an engineering problem or engineering system. Then while converting, what is the first step? Still you somebody remember what is the first step while understanding and converting the natural uh, system or problem into engineering? What is the first step we must do? Now, these questions again and again in every class they will come. Okay. Only thing is, if it is a direct class, I will take names. Yes. Cause and effect. Cause and effect is used when we look at when we are thinking about the direction. So that is not the case. What my question is, when we are actually, yes. Somebody said, Animesh said that it is parameterization. Am I right? So if you want to change something, some of your understanding into an engineering problem, or if you want to understand something into something in terms of engineering, then you have to convert that into a parameters first. So parameterization is the first step for that any concept or any problem or any system. So once you parameterize something, then you are actually grading down that to your level of understanding. That means engineering level of understanding. So once you degrade that, not degrading, you just convert into the engineering problem or engineering system. Once you understand that, you are going to define all the processes which are needed in order to realize that system or realize that idea or realize that technology. So if you write everything, then that is called concept document. Okay. So concept document also we discussed, and we came across some examples. One example is hierarchical construction. So what is hierarchical construction? Anybody? Maybe you can switch on your mic and say. What is hierarchical construction?
Superposition of several variable parameters.
Yeah, superposition of several variables or parameters. Okay, not variable parameter. Parameter means which is varying. So superposition of different parameters you can consider, or superposition of different patterns. Okay, so that is a generalized way of understanding the things. This concept you can apply anywhere. There is no limitation. You have to apply only in the case of physical or cyber or cyber physical. Anywhere you can apply the idea. Okay, so that is what the hierarchical construction we understood. We took some example, and this example which you are seeing on the screen is one example which they used in order to calculate how this kind of hierarchical construction, that means multi-parameter construction, is helping to stop a bullet that you can clearly see in this case. So in this case, what is happening, you just have a look at it. So in this case, if you see here, this one, the impact of the bullet is very minimal. There is an impact, but very minimal. Whereas in the case of this, it is almost made a hole. So that's the reason why, if you go to this one, the structure you can see. So this is the superposition of different structures or different patterns. It's not a simple single structure. So that is what mean by superposition of different parameters. That means different patterns you are overlapping on each other. Okay. The mixing may be of any kind, because nature can mix in a very sophisticated manner, which we cannot do that. But within our limits, can we overlap one pattern on other pattern? If that is possible, then it's fine. Okay. So they are all working simultaneously. So bullet is not stopped only by the upper layer. So these all layers will contribute to the strength of the material or strength of the structure. So that is what demonstrated here. I'm going to show one more example, which I felt we have to discuss separately, because especially when you are dealing with the complex algorithms or complex systems, cyber physical systems especially, how we are going to consider the inspiration is the most important thing. This creature, which we call as a stomatopode. Okay, so and what is the significance of this stomatopode is mantis shrimp or stomatopode, both we call. This mantis shrimp or stomatopode, this is the oceanic species. In this oceanic species, one particular observation they made, actually two very important observations they made in the case of this one. One is its eyes. If you just have a look at the eyes. Okay, one is its eyes. If somebody, I think most of the people attended my intelligence systems class. In intelligence systems, I definitely mentioned this particular case, because they have a localized intelligence. Each eye will process on its own. Okay, the information will not go to central system. Each eye will process the information locally. Okay, it is like it has real two eyes, because we are seeing that I have two eyes. No. One eye is looking, other eye is also looking. But if you close eye also, you can actually process the information in the same way. But maybe we have to call this as a stepney. But it is not working like that. Each eye is independent. Okay, that is one observation they made. That comes to intelligence part. Okay, then it has you can see the structure here. It has a leg kind of thing, that means hand kind of structure is manifested in this system. Okay, so that is of our interest now. Why? Because if you see in this this particular structure, this one, this is like a punch, almost like our fist, So this architecture of this particular structure, if you see, this is very strong, even stronger than the nacreate shell, which until that point they were considering is the strongest material, because I have shown you nacreate shell previously, this one also. So this kind of structures they were considering, as per the parameter measurements, they were considering they are the strongest things. Okay, so this kind of things, these kind of arrangements are the strongest up to that. But once they observed this particular structure in stomatopod, they realized that there are stronger structures than nacreate's shell. But here, what is the important thing we must consider is, you just have a look at it. Maybe I will consider this as a hand, okay, because punching hand. This one, if you just see the cross-sectional structure, it is a hierarchical construction, no doubt about it. So microstructure you can see, it's a layered structure, point number one. In the layered structure also, again you have some cuts. That means it is layered structure in 2 dimensions. That is very good. But here, nature introduced one more parameter. Here, if you see, the second layer in the x-axis direction is not a simple x-axis direction. It is like a kind of a twisted structure. Okay, like sphere. So it's a kind of a twisted structure. It is shown here. They are not only going like this, they are also twisted. Okay, so that is actually giving some angle here. Okay, so one more parameter came into picture. If you see here, there are 2 layers. If you see here, there are 2 layers. So one is in y direction, there is a layered material. X direction, there is a layered material. At the same time, within that material, there is again the substructures. We will agree with that. But here, if you see, here one more parameter we can define, that is angle. You can see like this. Okay, so that angle actually making the difference. That means that angle, the twisted, within the twisted fibers are bringing the some more strength. Okay, so that is what you need to understand in the hierarchical construction. In the hierarchical construction, if you are really can introduce one more parameter of variation within your system, that may be cyber system, that may be cyber physical system or physical system. Okay, if you could introduce one parameter in its structure, that means you must satisfy or you must design that parameter also. That is also a variable. Okay, so when you really introduce one more parameter of then that system becomes stronger and stronger. So that is what we need to observe here. Nacreate shell is very strong. We agree with that one. Because of its structure, that is one layered structure in 2D and 3D. But here, along with the layered structure, there is a twist. There is an involvement of angular layered structure. So angle wise varying layered structure. So when that comes into picture, structure became very strong. That's why they call it as the strongest punch. Okay, what the velocity blow, that means punch it delivers, is 104 meter per second square. That is the acceleration, and 23 meters per second speed. You can imagine. Okay, it's not that easy. Okay, so 104 meter per second square acceleration punch it can give, and the speed at which it will give is 23 meter per second. And also that the strength of the material or strength of the structure, you can read here, complex hierarchical structures containing only small amount of organic, that is 5 to 10% weight, result in increase in toughness and material properties exceeding those of inorganic phase alone. See, organic is giving more strength. Okay, that is surprising. Okay, we are thinking that inorganic will give the higher strength. So that is what we can observe here. What, as far as bio inspiration is concerned, you need to observe that you always remember in mathematics, if number of parameters are high in a function, then solving that function is going to be difficult, or the form of the function is going to be complex. This everybody knows. In your mathematical physics or engineering, you must have learned it. The same way, in these structures, if you are building a system with multiple parameter variations, then system is going to be complex. Okay, so naturally computer science students are who are working on the cyber physical systems, they think that this is going to create, or this kind of structures we need to create firewall systems, to antivirus systems. At the same time, the stronger intelligences also we can create with the inspiration of this kind of that means it is not a single parameter dependent, it is a dependent of multiple parameters. So failure percentage is going to be, no, some cases it is high, but if it is working fine, definitely it is going to be a very effective system, even as far as intelligence is concerned. And physical properties anyway they will improve. So that is the reason why. So this hierarchical constructions, introducing the new parameters of variation, is going to work as a add on to your physical properties, add on to your cyber properties, add on to your cyber physical properties. This is one example like that. So in this, if you see, they probed it further. You can see how angle is varying here. So this kind of structures, if you could create in different systems, then that parameterization anyway they did spacing, all those things, but angle plays a very important role. That means with respect to the x-axis, there are two variables, angle as well as the spacing. So with that, when they tested, it is clearly visible that the impact resistance was very good in the case of this kind of twisted structures. So that is what the hierarchical constructions I wanted to introduce you. So hierarchical constructions are the most important structures in nature, because nature always deals with the complex structures. Complex structures means we define them as hierarchical construction. Hierarchical constructions means we consider them as an overlap of different patterns. That means all patterns will be active simultaneously. You can understand. All patterns will be active simultaneously. All patterns will contribute as a single pattern. Okay. So, and these generally depending on higher number of parameters, 1, 2, 3, 4, like that. Definitely not one, many parameter structures. So there will be many parameters. Second, all patterns which you are considering superimpose and work like a single pattern, and all patterns are active at simultaneously. Okay, so these particular inspiration points you must consider in order to build any hierarchical structure or any hierarchical system in your domain. So those are the hierarchical construction bioinspiration, and which is the example for one very good example for how you are going to understand the nature. So insights how you are going to bring into your level of engineering understanding or your level of design understanding. Okay, so that is about the hierarchical constructions. Any questions are there before going to the next topic?
Just like one small question, sir. Like
Yes.
after observing the like at a microstructure level, the organic that punch, like that kind of material, how it's built in a hierarchical way. So how we are building it, like from here. So how we are building it, like in real life. What kind
In
of
real
manufacturing
life,
process or something?
manufacturing process is the complex.
Because I can't imagine with what I have read in college books. Or...
No, 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 no. It is like, see, manufacturing methods don't think always we follow the conventional manufacturing methods. Okay. So we have to come up with a new kind of manufacturing methods. That means with the existing manufacturing device itself, we have to do some variations in way of manufacturing. Because now you see, we are making the layered material. Let us assume we will do that with the sputter coating or something. Okay. That will take 1 hour time. But here what you need to do, it is not only simple layers. With respect to layer, the spacing should change. At the same time, orientation also should change.
Yes, sir.
Right? So that will take more time. That means you have to layer by layer, you have to design slowly. It may take 10 hours.
Yes.
Like that. So that is what the manufacturing level you have to define. Maybe you will define a new method in order to make this easily. So that is a manufacturing problem.
Right.
So from where you are going to build complex structures. No, you are not going to build a complex structure. You are going to build a machine which actually make complex structures.
Right.
Okay? Because anybody thought about it, especially mechanical and electronics people, you are using the PCB printer, and PCB, other form of the PCB printer is 3D printer.
Right.
Okay, both are almost same only. 3D printer. Why always it is horizontal? If your extruder is with some angle, will there be any problem?
Yes, sir.
Yeah, definitely. You say problem, but you didn't try at all. Because you can use the vertical one at the same time angle. Why you are using only one extruder? Can you go for 3 extruders at a time? In 3D printer or PCB printer? Both I am asking.
Yes, sir. Yes, sir. There are multiple.
Yes, that kind of a complex manufacturing unit we should create.
Right.
That's why future of automobiles, they are saying that can you build a complete car with one machine? That's it. It's a single go. I want to build a car.
Wow.
Okay, it's like a 3D printing only. So, but that 3D printing, our conventional thinking is first I have to work on the 3D printing, which do the 3D printing of the metals. Okay. By the time foreign countries will overtake us and they will build some new concepts. So you should think out of the box in such a way that, okay, in order to create a complex structure, instead of dealing with this machine which is existing, can I build a new machine which can build the complex structure?
Yes.
That way we have to think. That way even bio-inspiration is very useful.
Right. Yes, sir. Thank you.
Yeah. So that is the thing. Any other questions? So hierarchical construction as a concept you can take up. At the same time, as an example for how we understand nature also you can take it up. Both way you have to understand. Okay, tomorrow onwards, when you see some natural system, you should not ask how to understand this natural system. Okay. Next. So while understanding the natural systems, we came across this the way of understanding the natural systems. This one. So first you consider manifestation of knowledge, then information flow you want to create, then experience under certain conditions means that information flow you must get and analyze. For that you have to create some conditions or the directions. Then you go for interpretation. When you are dealing with this particular system or this particular step, that means you need to create your direction. I told you already that you need to create the direction, which direction you want to work. That direction mostly given by your problem. Okay. So, but you must know some resources where you need to search. Am I right? So you must know, suppose I want this particular function. Then you search in Google, that is the first option we'll do. Because we are not going to library and searching for these things. There are no dedicated libraries for, I'm talking about physical libraries, not e-libraries, okay? So there are no dedicated libraries for this, but you have to search in Google. The second option here is, in order to search the direction, in order to have search for your keywords, okay? That means if you know the keyword, where to search, that question definitely arises. So that is where there is a resource called Ask Nature. Okay, maybe you can note it down. Ask Nature, if you go, so in Ask Nature, you can with a particular keyword you can search. So Ask Nature, how it works is, you have to give that functionality. You have to give the functionality which you want to probe. Then it will show the different species in that particular with that particular function. You can actually give a keyword related to form, or you can give a keyword related to function. Okay, so that keyword, whichever you decided based on your problem, you can go to Ask Nature and probe. Okay, then some initial inputs will come at least. So when initial inputs will come, then from there you can start your journey. Because last time somebody asked how we have to decide which system is suitable. Okay, so Ask Nature is because other things are biolog, which this system, biolog system seems it's not working now. Okay, Dane anyway you can work on. You just look at this one. Okay, this is developed by some not Indian, it's a Indo-US professor only. So this is also based on the functionality. It's a database of biological solutions. Based on the functionality you are giving as a keyword. Okay, so this is by Georgia Tech University. So Dane as well as the Ask Nature are the two resources where you can start your searching for bio inspiration. What you need to give? You need to give the functions especially. So you must know about function. How you decide the function? You decide the function based on your direction. What is your direction? Your direction mostly driven by the problem you want to solve. Okay, so in the Ask Nature, this is what you are going to observe. So nature to transferable of idea, then possible product, then actual products, digital downloads, Autodesk Inventor. So many options are there. You can go and have a look at it. Only thing you must have with you is a keyword. That's it. If you have a keyword, then you can search for something. But the Dane is different because it is also not working right now. I think that project they stopped, it seems. But you can download and try based on the functionalities and based on the keywords you have. Okay, so those are the two resources and two important resources which you can explore. And anyway, you start with Google, so that is not denied. At the same time, as I told you, that may be the documentaries especially related to biology. That means National Geographic Channel, and especially this Curiosity also giving really good insights regarding the nature. So this you have to keep looking, because you can't say I'm going to get the idea or I'm going to get my solution somewhere, exactly this place. If you want to exactly find, you have to go with start with Ask Nature, then you get some insights, then after that you start probing towards some solution in the nature. So that way you can do the complete process. So that those are the different resources which you can use. So if you want me to open here, so innovation inspired by nature, that is the call. So hope you are seeing my screen, right?
Yes, sir.
Yeah. So here you can have a search. So search, see that, enter the keyword. So they have very good collection. I wrote in the PPT that is 1300. Now the database is increasing day by day. Even you can add, I think. Okay. So maybe if you can become members also, that would be really good. And there is a biomimicry institute separately. Don't worry, because biomimicry is something that is different. There you can do bio inspiration also. There is a separate institution called Biomimicry Institution, Biomimicry Institute. I think it is in Netherlands, I think, Netherlands or Switzerland. So I'll open here. So what is the keyword you want to give? Let us give strength. See, this is my keyword, and this is what the strategies came. Okay, different perspectives of strength. Okay, mechanical strength, and here structural weakness, how to avoid that, and here support the growth part due to the pollution walls. So different perspectives in the nature related to strength. Suppose if you want to search for uh, any different keyword, any other keyword. So, and you have one option here, that is innovation also. So that innovations also you can browse through. So sectors aerospace, one innovation, see stomatopod is there. Strong and durable composite technology inspired by mantis shrimp. Okay. So this is the one important that is in aerospace, architecture, infrastructure, manufacturing also, 4 are there. So manufacturing, residue-free adhesion technology inspired by Gecko. This everybody know, I think. By the time people know Gecko, even the name of that sticky thing is Gecko. Okay, and this durable 3D printing. I think Ravi asked this one only. Durable 3D printed concrete inspired by lobster shells. Okay, now you can think about what kind of problems we are working on. We have to work somewhat the advanced problems, and so these kind of things. So blemish free gripper inspired by geckos, again it is on robots. Okay, so those things you can definitely explore with respect to different keywords, and this function was not there previously. I think they gave recently. Now they categorized into biological strategies, that means the general inspirations, as well as innovations already came. These are innovations already came. Okay, so this way you can search, and this is very important resource for you to start with. But I am not saying that everything you get here, no, but as a starting point, in order to search the inspiration, definitely you can start with Ask Nature. Okay, And as a just a entertainment, you can have a look at the documentaries related to nature, documentaries related to bio-inspiration and biomimicry, documents related to different species, document related to natural systems, that may be solar system or galaxy or any species like stomatopod. So you can see the documentaries like entertainment. So you start getting ideas, okay, futuristic ideas. Don't stick to because last year one of our students attended some interview in some so-called top institution in India. Okay, because the mindset, I will tell you, not IIT Madras. Okay, that is my mother institution. I am not telling about that. So they asked that she was talking about the 3D printing, bio-inspired 3D printing, which was inspired by this what is spider web. Okay, spider, because spider is an excellent 3D printer, right? It's a 3D printer. It can do 3D print. Spider. So, and it can move X and Y, Z directions. So it is like a movable 3D printer. So when she presented that, they only saw the negative points in that particular concept. There are negative points that may not be the technology of today. But tomorrow, building technology may change like that. We don't know. Because already, I don't build the, what you say that like China, biggest 3D printer in order to print the house. I don't do that stupidity. But I may build some 3D printers which can, like our wage, daily wage workers, they will just go and build the thing based on 3D printing. Different parts are built by different systems and just will join them together. That is possible. Okay. So, but they saw only negative points in that. They didn't see the futuristic perspective in that. Still, they were talking about the welding, these things. So this attitude should go off. We must work on, of course, I will say practical problems we have to work on, but at the same time, they should be futuristic. So that futuristic ideas you can get from nature. Definitely you can get. So whatever you call as a radical thinking, that radical innovation, the radical innovation, one source where you can get radical innovations is nature. Because it is evolving from billion years. It has all the things with it. So that's the reason why. So you please have a keyword, just make it into a habit, because there is no course, or sorry, there is no area you can say that no, bio-inspiration not applicable here. Will you take management, you take computer science, you take electronics, you take mechanical, you take physics, you take anything. Just matter how you understand that inspiration. Based on that understanding, you can apply anywhere. So that is what my suggestion. So you please have a look at these resources. Then this Biomimicry Institute also, you can become a member. So now those are the people who created this. Even they are running this. Sorry, Ask Nature also. This is the Biomimicry Institute. And you can see all the things related to biomimicry, and you can become a member of this Biomimicry Institute also. They are offering some courses, but the course is in, I think it is in Netherlands or Switzerland. You just have a look at this our initiatives. So K5 Education, you can see they are actually going for some challenges also, Global Design Challenge. So these are all things you have opportunities in bio-inspiration alone. I don't say all 90 members will get opportunity, but 10 members definitely there is a scope as a career. Okay, other people can apply in any area of the thing. So please have a look at Biomimicry Institute also. You will come to know. So Ask Nature you start with, then you go for Biomimicry Institute, then you get all the resources. Hope that question I answered, which asked last time. Okay, so that is about the today's class. We completed the hierarchical construction, and I introduced what are the different resources you can have as far as natural inspirations are concerned. Now, next, what we are going to do in the module 2 is related to uh, the two different methods. One is, we call it as Acrex method. Okay, another is BioTriz. Triz you know already. Okay, hope people at least have heard about Triz. Am I right? In first year or somewhere. So Triz method, in the biological perspective, I have very good examples which we did here in this institute. So those things, the two methods I will introduce. So once the methodology is over, second module will be over. Then third module, I will introduce different perspectives. That means how nature has a control systems, how nature is a sensor, sensors wise, how you have to look at nature. As robotics, how you have to look at. So these things I will introduce slowly. That's it. If you have any questions, you can ask. And Hema, you please take attendance.
Yes, sir, I do.
Yeah. So another 10 minutes, you can ask any other questions. The first module is over. If you have any questions related to the concepts we covered, you can ask. Next, we are going to deal with two very important methods in order to get bio-inspired solutions. Okay, those are the two very important methods which we can practically use in any area to get some solutions, bio-inspired solutions. So, and also this semester, I just would like to ask you your opinion. You please let me know, in this semester, shall we work on a single problem to everyone, or shall I give, like last time I gave 4 problems and I asked people to choose to apply these concepts. So this year, shall we work on single problem so that everybody work on the single problem, or you go with your own problems? What is your opinion? Anything is fine for me, because online, right? I have to give little freedom to you. That's why I'm asking.
So we will go on our own different
Individual problem. Okay.
And one more, sir, like
Somebody said single problem. Someshwar.
it would be better also, like if you can provide some options, so that can give us some direction also. Also, then.
Okay. Single problem. Anybody else?
Sir, it would be better if we can choose on our own.
In your own. Okay.
Sir, I agree with Ravi, sir.
So 4. You are saying I need to give some options, not like
Yes,
a
sir.
single problem. Okay.
Yes, options and also the freedom, for us, like at least who have a single individual problem, they can take their own. And if anyone does not have, they can take from the problem.
Yes, sir. I like that.
No,
So it's like a combination of both.
because this course, I don't want to waste your time. Mostly I want to discuss on the problem, especially our country is facing. Okay, especially that if you see in the border, these rats beside one country is there, right? That Pakistan. These fellows are digging and coming inside that underground tunnels. So that kind of problems, I have several problems, so that all the members will think on the single problem. That is one way. But there is a lot of opportunity for copying because I can't avoid that. But maybe some people may work sincerely. But I can give like that 4 or 5 problems. You can choose one. That is also like giving options. You can choose one. And the third option is you can choose on your own, your own thing. That means, but you only will work on that. So which way you think better? In this course, I am not going to waste your time with stupid problems. Okay, don't worry. I'm going to give the problem which are relevant to India. Okay, to be.
Sir, 2 and 3.
Better to have both, sir. Like whoever want to do by their own, that's also fine. And if you also providing some options, so it also fine if someone want to choose from them. There.
Okay, you are proposing intermediate methodology.
Yes, sir.
I'll give 4. If you want, you will choose on your own also. Is that?
Yes, sir.
Yes, sir.
Okay, in that case, we will go with that. Hope everybody fine with that, right? Because most of the people saying single problem, that single problem option anyway I will give you. Okay, because I will give 4 means you have to choose only one. I'm not saying you work on all 4. No, single problem. You can choose one and work on that, because most of the people are good with single problem. So I will search for 4 relevant problems for India. Then I will post 4. But I'm like last time, I'm not going to compel you to choose. But if you have your own problem, you can choose that also and apply the bioinspection. Okay. So by next week, I think I will post those projects also. Okay. And also I would like to. Yes.
Sir, is this an individual task or group task?
Individual.
Okay.
No group. Okay, it can be done individually, because method you have to learn, right? So let it be individual. So and this year I think if somebody are interested or somebody are free, I have 2-3 ideas. Okay, so please free in the sense, if you want to work on something, then I invite people to join with me, especially bioinspiration problems relevant to our country. Okay, so who are having some time may contact me. Okay, so that's it. Any other questions you can ask? That projects I will post by next week. Okay.